limit of x times ln of x as x approaches to 0 from right-hand side. Okay, x approaches to 0 from right-hand side. Well, remember the graph of ln? Let us try to analyze what's going on here. This is our x-axis, this is our y-axis, and this is the graph of ln function. Graph of ln behaves like this. So, as we go toward 1 from, okay, let's just write down. As we go toward 0 from right-hand side, where does my y value go? My y value starts going downward. So this guy, as x approaches to 0 from right-hand side, goes to negative infinity. Well, this guy is just line y equals to x. So this is ln of x. And then the next graph is the graph of y equals to x. As I'm going towards 0 from right-hand side, well, my y value goes to 0. So what I have 0 times negative infinity. 0 times negative infinity. But what is the value of 0 times negative infinity? 0 times negative infinity. This is another case of indeterminate form. What should we do when we have a case like 0 times infinity, 0 times negative infinity, 0 times positive infinity, and so on? So note that when we have 0 times infinity in general, or 0 times negative infinity, we need to make some adjustments. What adjustments? The adjustments that help us to rewrite the function. So when we are taking the limit, it is going to be 0 over 0 or infinity over infinity. So that the limit becomes infinity over infinity or 0 over 0. How so? I'm looking at this function. This is x times ln of x. Well, go back to intermediate algebra. Go back to elementary algebra. This is x. If I write this as ln of x divided by 1 over x, they are equivalent to each other. Here, if you multiply x by ln of x on the denominator, you end up with 1. So you get x times ln of x. So it means that since these two functions are equivalent to each other, their limits must be the same. Well, okay, let us start taking the limit. Limit of this function as x goes to 0 from right-hand side is equal to the limit of this function as x goes to 0 from right-hand side. Now, what is the difference between them? The difference is when I take this limit, it gives me 0 times negative infinity. If I take this limit after substitution, remember that the very first step is substitution. ln of 0 from right-hand side. 0 from right-hand side divided by 1 over 0 from right-hand side. Now I'm dealing with this function on the denominator. 1 over 0, 1 over x is the reciprocal function. The reciprocal function. This is 1 over x. It has two parts. As I go to 0 from right-hand side, well, my y value goes to positive infinity. So I have 1 divided by 0 from right-hand side. For ln, I have negative infinity. For 1 over 0 to the positive, or your reciprocal function, you get positive infinity. Well, we just learned about L'Hopital's rule. It says as long as you have 0 over 0 or infinity over infinity, negative, positive, it doesn't matter. You can start taking the derivative of the numerator, taking the derivative of the denominator, and take the limit one more time. So we're not dealing with this function. We written this as f of x divided by g of x. This is your f of x, and this is your g of x. So let's apply L'Hopital's rule. You have the limit of f prime. So we are taking the derivative of ln. We divide that by the derivative of the reciprocal function as x approaches to 0 from right-hand side. Well, the derivative of ln is 1 over x. The derivative of 1 over x is negative 1 over x squared. And we are finding this limit as x goes to 0 from right-hand side. But let us simplify this first. Simplify. When you simplify this side, what do you get? You get x squared divided by negative x, or just minus x. This is equal to the limit of minus x as x goes to 0 from right-hand side. Well, you have a line. This is just a very nice function, linear function. To find the limit, you just use substitution. By substitution, you get 0. So the limit of this function as x approaches to 0 from right-hand side, or the y value of the function, is just 0. Y value vertical. Very well. So what if we have something like this? The question says, find the limit